If she's Middle Eastern, then a prostitute just means a woman that has a lot of guys over.
Hello, Matthew.
Hey, Jack, good afternoon. How's your weekend?
Pretty enjoyable so far.
Great. Well, you must want to do some math.
Yeah.
What's going on? What are we gonna look at today?
Just a calc project. So I can, if you can make me the host and share my, oh, okay, you've already done that. All right,
Yeah.
here's the project itself. I just wanted to get this over with.
Okay. Let me is there any way you could just download and either email
Oh,
or
I could do that. Yeah.
uh even
Here we
drop
go.
it in the chat, whatever is easiest for you. And
Like,
I'll share my screen on my side so you can
I just sent this to your email under the booking.
all right. Having any allergy problems right now with the change of season?
I I had a little jet lag because I went to New York for a day visit at West Point.
Cool. Oh, what a great place to go.
It was really beautiful, man.
I regret never going to a football game there. It's really a pretty special place. Um,
Yeah, right after I accepted the prep school request. So I'm gonna go there in July.
cool. Right. So let me share my screen and we'll go through this. If I recall, do you need explanations or do you just need is it just the steps? Are you writing anything here or just showing work?
Um, Show work and yeah, I think I've already done up to number 3 right here. I'll
Okay.
look at this.
So I'll have to probably work through this here. It says a typical dose is 10 milligrams taken once a day. It's eliminated from the body at approximately 2.3% per hour.
Mhm.
So there's your K. Your K is 0.023 and your P0 is 10. So your P of T, we're just substituting values, nothing to do there, minus 0.023 times T.
Yep.
And that's it. There's nothing more.
Then you substitute 24 hours in there and you get
Oh, I'm sorry.
5.76 milligrams.
I'm sorry. So yeah, that's an important consideration here is that your time is in hours.
Yeah.
So yeah, P of 24. Sometimes these problems move between days and hours. Do you need me to calculate that number to confirm what you got, or do you feel comfortable with it?
I'm comfortable with that. Don't worry.
Okay. So number 2. So to be clear, this equation I just wrote is how much they're going to have after the first dose. This is for the first dose because they're going to take a second dose. Okay. And what's the amount, how much do they now have in their bloodstream? So there's a couple of ways to do this. It doesn't say to write an equation. So we know, what is this number, by the way? This after
5.76. And then
5.7.
in number 2, I think it was the teacher that went over this with us. You add 5.76 to the 10 milligrams from the
Exactly.
once daily, and you get
Exactly.
15.76 milligrams.
Yeah, exactly. There's actually a few different ways to do this. If you ever take any financial classes, this is essentially what they do with time value of money when you have multiple monies that you're putting into like a cash flow diagram. In our case, like if you're preparing for retirement. But yeah, I mean, that's how much was there. Here's the new amount, and then it decays at the same rate. And then how much will they now have in their bloodstream?
And
So are they saying at the So like this is at T equals 24 hours.
Yeah.
Okay, but are they asking how much they will have now after another 24 hours or after?
After
Oh,
adding a dose, I
I
think it's
see.
just
I see.
5.76
I
plus
see.
10.
I see. I
That's the
see.
whole
Yeah,
rate.
yeah. That is all there is here. Okay, thank you. So 3 is what I was referring to, which is now they've done this. It's 5.76 plus 10 e to the minus 0.023 times 24.
Mhm.
Okay. And do you have that number?
This is the part that I
Okay.
left
So
off on, so I need to calculate too.
I'm gonna get it here for you also.
I will be confirming it. 15.76 into the
They actually give it to you in the table to confirm. It's down there in the next line, but the 9.07 milligrams. Oh, and that's important here. We probably need to show work.
yeah, again 9.07 milligrams.
Okay. All right. So
Alright.
the next thing here is filling out this table.
We're basically just adding 10 to like 9.07 there.
Yeah, for this one, this line over here is always that plus that, and then I'm sorry, the one on the right, you just add 10 to whatever's on the left. Okay, but then to get this new number on the left, you have to take the 19.07 e to the minus 0.023 times 24. So what I was going to do is actually make a little spreadsheet. Alternatively, we could do this in the calculator. Does it matter?
You could do it in a calculator. I just need to know how to, I would like to know how to do it.
In a calculator. Okay. So let's do this. Let me find that tool. All right, so I'm going to new share here. All right, so I'll start out by letting so we have 10.
Mhm.
Actually, let me make that X. So we're gonna do 10 and we're gonna store that to X. That's STOX. Enter. Okay.
All
And
right.
then we're gonna do X and then we're gonna do E. This is a little bit backwards from what maybe you're seeing, minus 0.023 times 24. Okay. And you get that number there, which is what we expected. That's what we, so nothing new yet. Okay. So now the only thing that changes each time is the X. So you take your answer, second A and S plus 10, and you store that to X. Okay. Now, if you're following what I'm doing exactly, you got to do this exactly. This is where the speed of what I did comes in. So if I go second entry, so this time when I do XE to the 0.023 times 24, it's using that new X value. And you're going to see that gives you the 9.07, nothing new. Okay. But then when I do second entry again, that's my new X, 19.07. And now I just repeat these two lines over and over again until I get down to the answer. So the next one is 10.98. And I'm
That's
going to
pretty
write these down.
cool.
Yeah. Well, it's really, it's like they should be showing you this in the classroom, especially they're going to ask you to do this. There is other ways to do it, but it actually gets to be kind of slow for when we're on a computer because we're used to just doing things so quickly. So obviously you add 10, 20.98, and then you do second entry. Again, that gives you the new value. Okay.
12.08.
So I'm going to eventually make a mistake. So I was going to actually grab a spreadsheet to do this because you can see it's 22.08. But let me do it real quick. We'll take under a minute and then I'll fill in the rest of the table.
All right, I'm filling it in, and then you can
Oh, cool.
pull up the spreadsheet, and then we can confirm that.
Sure.
So it seems like it starts to fall off a little bit. It goes from like 15, 19, then 20, 22, and then it's like by a small increment. It goes from like
Yes.
22.08 to 22.71 on the right.
So when you take a medication, and we've almost all done this in our life, that's why they only give you a certain amount over a certain number of days, because eventually it doesn't do anything.
Mhm. $2.29. They want it to the 2 decimal places. I'm just gonna do the 2 decimal places. 22.29.
We said 2 decimal places here. Okay, so let me grab this. So if you're seeing my screen at any point here, you'll see the values.
I got all of them. Awesome.
Fantastic.
And to the second page.
All right, let me get caught up to here. So there, I looked ahead. It said something about they're like saying like, can you do this in a way? Oh, run logistic regression as demonstrated in the lecture for your completed data table. Okay. So what they are doing here in part 5, and I'll have to show you this in the calculator. They're saying go to your calculator, and we're going to put in the values in this total column into y1 and then y2. So I'll go back to sharing my calculator so you can see that. Okay, so you go stat, edit, and then L1, sorry, L1, and that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you go over to L2, and this is where you got to enter the numbers that you found from the previous part.
And 2.76. 5.7.
All right, so if you have that entered in, let me know when you do. We'll move on to the next part here.
5.52. All right, just got it. Oh, I think I did this out of order. All right, so 10, 15.7, 19.07, 20.98, 22.71, 23.08. I feel like I skipped one. 23.29, 41, 48, 52.
Very,
Could you scroll up a little bit? On my
uh,
calculator?
yeah, let me see if it'll do that.
Let's see what I missed. It's 20 point. Did I forget 20.98? I think I forgot 20.98.
Unfortunately, it doesn't have an insert, so you just have to rewrite them all.
Oh, I put it at 0. That's why. I'll get rid of the 0 then. So. Never mind. Can you I think we can move on.
Okay, what I do here is I always second quit, except there I did something completely different. 10, well, that was dumb. Second quit is what I do to always get out. Stat, calc, and then you go down and you're looking for logistic regression right there, 8. I'm sorry, B.
E.
and you hit enter. Yours may see, let's say like Y1, Y2, or L1, L2, and then you just hit paste. Oh no. Oh no. Stat. It did insert, didn't it? Boy, I messed this up bad. Okay. Second.
Yeah, I think I had something like that with the 0, 10.
Okay. Delete. There it is. Okay. Now it should work. Stat, calc. You can actually go up instead of down. Please work. So the calculator is running. Yours will actually run a lot faster than this. I don't know why this one is so slow. It will actually eventually return something. Come on, come on.
I should do it. I think I'll go and try to do if I might do the little graphic in. Like, was it,
There it is. So the formula, and I'm writing this down. I'll share that screen in a moment. They give you the formula. And they give you the numbers here. One of the things you gotta be really careful of though is like whether there's an E to the minus something. There is not in this case, but very easy to
miss it?
miss it over. I'm sorry, I will get the wrong numbers already. So I'm gonna go to 4 decimal places. I don't have like really a reason why, but I find I don't go to enough, and this seems to always make it work. So 1 plus 1.2502, that's a 3, e to the minus 0.858 t. All right, so I'm going to share my screen, a different screen, and you'll see that what I've done is written down the model and then the numbers that go in the model. And that's what they're looking for 5. This is the answer to 5 down here. Oh, and you do need to fill in this table with these values on the right here.
So it's 1 point, so it's C over 1 plus AE to the
Yes.
negative BX. Then you substitute for 23.3036 divided by 1 plus 1.2503 e to the negative 0.58. Oh wait, 8.858. 0.858. T. There we go. Now it's for number 6. Use your derivative rules to find a model for the instantaneous rate of change for the amount in the bloodstream as a function of time and hours, A prime T.
Yep. So just I put it as P. It is A of T equals this. So A prime of T is going to be it's not quotient rule. It's actually just power rule. Everything up here is with chain rule. It's actually another way to write A of T is like this: 23.3036 1 plus 1.2503 e minus 0.858 t all to the power of -1, and then it's just power rule when you take the derivative. So keep that in mind. It's not a quotient. So you bring this -1 down in front, so you get minus 23.3036. Keep the inside stuff to the -2 power. And now you have to take the derivative of the inside function, this part in here. The derivative of 1 is 0. The derivative of e is itself, okay? But you have a little chain rule to go along with it. It's 1.2503 e to the minus 0.858 t, but then you multiply by the derivative of this e minus 0.858, like that. And I can clean this up also because there are some things that multiply together that you'll want to include here.
858 t and times negative 0.858. There we go.
Oh wow, this actually worked out. Instructor chosen guys. So when you take this number on the left, the minus 23.3, the 1.2503, and the minus 0.858, you get basically 25. It's 24.99999. It's 25 over, actually there's a little more here, e to the minus 0.858t over 1 plus 1.2503 e to the minus 0.858t all squared. So again, all I did is if it's a negative exponent, I move it to the bottom. I combined the three numbers. I combine these three numbers, and then the e just comes down with it. So this is your nice compact derivative that you'd want to box in so that your instructor isn't going all over the place to grade it.
Alrighty. On number 7.
Okay. So number 7, part A, is 2 days. Now our model is not in days, it's in hours. So part A, 7A, 2
24 times
days.
2.
Yeah, 2 days means 24 hours. So you're going to put t equals 24 into this model up
It
here.
wouldn't be 48 though.
I'm sorry, 48. Yes.
Okay.
Okay. And what I'll do is calculate it also at each of those points. Ooh. Get a pretty small number here, which is a little bothersome. I wonder if I calculate this correctly. So for the first one, I get a prime of 48 is 3.25 times 10 to the minus 17, which is essentially 0. Do you have something similar?
I do.
Okay. And so that's why I don't understand, because it's only going to get worse, because the way the logistic curve works is it goes up like this, and there's basically no change. It's basically 0 after a certain amount of time. So t equals 96 is your next one.
Mhm.
And it's going to be very small again. It's going to be basically 0. So it must be, I guess I can confirm this with a graph. This is 4.27 times 10 to the minus 35. I mean, it's basically 0. The next one at 6 days will also probably be 0. I do want to graph this because I really don't like how it's not, being reasonable with us here. So you get 1.25 divided by wait a second, did I? Yeah, I did. Okay. All right, I'm just graphing this now, and I'm gonna have a nice window for you here. 0 to 100. What do we say, 25? Wow. Yeah, so it really, is there any reason to think we didn't get the data in the model right?
I don't know.
So what I'm looking at for this sketch here, I'll snip that in, is that basically it goes to the what's called the carrying capacity, which is that final amount you saw on the table, the 25 grams pretty quickly. So let me try to explain what I mean by that. So the model here is And I'm going to snip in the one that I'd made from the equation. It gets there so quickly. So I did it. Let me change this slightly. Let me change the window here. Let's go. No. 0 to 25. Let's go. So this is just like in the first 12 hours, what I'm seeing. Let me snip this. It really hits its carrying capacity pretty quickly. So the graph here, you can see that it really, like, it goes up to that 25 really quickly. I mean, this is in the first 12 hours.
Wow.
And so like what they normally look like is where you have the starting point and then it goes up, but like usually it takes a little longer.
It's a little out.
Yeah, like what I would have expected is, I mean, we don't want this for medications, but I would expect it's something more like that. But it's what this is trying to show you is the drug is effective right away. Like you get the dosage you need and it stays in your body relatively quickly. Probably the reason why we feel so much better when we get an antibiotic right away.
Yeah, that the instantaneous effects basically.
Yes. Yes. So that's a reasonable sketch. So that what'll happen is long term, it goes to what's called the carrying capacity, which is the numerator, which is 25.
4, 6, 8. Trying to do an okay sketch here.
This is from like 0 to 25. And this is about 10 where it starts.
So it passes through 20 at approximately 2.
So let me also, excuse me, let me also just check our calculation here. It really doesn't feel great. Edit. It does, it goes up so quickly. You know what I wonder though? I'm sorry. I wonder, oh, you know what? This is in days.
Mhm.
So this logistic model, that's the mistake here. This logistic model is in days, not
Hours.
hours, which means that we have to change these values down here. So this is not, it's a prime of 2. This is 2. This is 4. This is 4. So it is going to change these numbers.
Oh, so it is actually a prime of 2, 4, 6.
Yes, yes. And that now is much more reasonable because after 96 days, I mean, geez. Okay, so at 2, it's the correct answer is it's about 3 milligrams per day.
Mhm.
At 4, it's 0.75
0.75
milligrams per day. And then I think the last one was 6 days. 0.143 milligrams per day.
milligrams per day.
And so this is actually good here. You actually want to go out. I mean, I went out 12. I mean, you can see like within 6 days, you really get to where you want to go. This is days and this is milligrams.
Days, milligrams. What's different about does the graph still look the same?
Yes, exactly the same.
Oh, okay, good. It starts leveling out just before 5. At 25, I mean. And it just goes straight. All right, could you scroll up to the table so I can copy down the little numbers?
Yes, here are the raw data values over here on the right.
So
Oh, actually, I actually need both of them.
19.07, 20.98, 22.08, 22.71, 23.08. 23. 3.41. 3.48 and then 23.52. Done. That was about it that I wanted to go over. Thank you very much for your
Fantastic.
time.
Yeah, I'll send you the notes here shortly. Have a great day.
Oh wait, actually, one more question.
Oh, sure, go ahead.
Are you good with spreadsheets with Excel?
Yes. This is done in Excel. I can walk you through how to do it on your own machine, sure, kind of same format.
I have
Um,
a class that uses Excel a lot, and we have like these little projects. One of these days, would you mind showing me like how to do a bunch of this stuff?
Yeah, I mean,
It's
you
all
can,
online. And it's like accelerated, so I don't really learn it very
yeah,
well.
if you have something you need us to work through, it's just the same format. You just send over what you want to work on, and I'll either show it and you copy along. I don't recommend that you, well, I do, what I want you to do, and I'll tell you why, is I want you to actually do it, because the way that they grade a lot of these Excel projects is they do check the authorship, and they want to see that the steps are actually done and it wasn't just copied from somewhere else.
Yeah.
So you have to be very careful there in this modern age. Even just doing it on a friend's computer because you don't have your own could be a problem, or your sister's.
Yeah.
It's just weird. I mean, but
We
yeah,
can always
absolutely.
just we can always just do it. Oh yeah, you can't do it in person because I have my
It's tougher. It's actually a good way to, I mean, I would be looking at you, we'd still be sharing screens, but we could do it in person if that was important to you. But
thank you so much for your
yeah,
time and have a great day. I really
always
appreciate
always
it.
happy to help. Thanks, Jack. See ya.
Thank you. Bye bye.